In this video, I'm going to talk about linear voltage regulators and show you how to use one to charge 5-volt USB devices like phones and MP3 players. So what is a voltage regulator? A voltage regulator is a device that takes an unregulated input voltage that could be fluctuating over time and spits out a perfectly regulated constant voltage. For example, here I have a 12-volt battery that will be 13.8 volts fully charged and around 11 volts fully discharged. This 5-volt regulator will ensure that I get a constant 5 volts regardless of the input voltage, and the capacitors in the circuit will maximize the stability of the regulator's output. I'll show you this circuit on a breadboard later on. In the meantime, take a look at this. In an earlier video, I showed you how to make unregulated DC power supplies. Right now, the output of that unregulated supply is about 16 volts with about 2 volts of ripple on it. But if I add a 12-volt regulator, I get a constant 12 volts out regardless of what's happening on the input. Here's the same thing with a 9-volt regulator and a 5-volt regulator. So you can buy voltage regulators to get any voltage you want. And it's really not much more complicated than that. Basically, you have a higher input voltage that could change at any time, and the linear voltage regulator just clips all of that off, leaving you with a lower but very precise DC power supply. Even a terrible linear voltage regulator will give you an output that is accurate to within 5%. And newer voltage regulators have a thermal shutdown feature, which means I can't even show you one catching on fire. Pfft, progress. Now, how do I find a voltage regulator? Most voltage regulators begin with a few letters, then 7, 8, and then they have 2 digits indicating the output voltage. So here I have an L7805CV, and the 05 indicates that it's a 5-volt regulator. The LM7809 is made by a different manufacturer, and it's a 9-volt regulator. And on the right, we have a 12-volt regulator. You can buy these anywhere that sells electronics, Radio Shack, Jamico, Maplin, and a million other places because they're such a basic component. Just search for voltage regulator. You can also salvage them from old electronics. Check it out. I found a 3.3 volt, 5 volt, 6 volt, and 9 volt regulator all on one PCB from an old DVD player. And I'm not gonna lie, I didn't know these were all voltage regulators until I Googled the part numbers written on them. As always with engineering, Google is your best friend. Okay, so let's say you've got a voltage regulator. Let's say you've got an LM7805 for 5 volts and want to wire it up. Well, that's really easy. All you need is the regulator and 3 capacitors. 10 microfarads on the input, 10 microfarads on the output, and finally a 0.1 microfarad ceramic capacitor on the output. These capacitors help ensure the stability of the voltage output, and although you don't always need them, if you have them on there, the circuit is pretty much guaranteed to work every time. The values don't have to be exact, so if you use slightly more or less capacitance, it'll probably be fine. So let's give it 12 volts in, and at 5 volts out, you can see that it works. Right now, this circuit would be good for loads of up to 100 milliamps, but since I want to handle more current, I'm going to put a familiar looking heatsink on it. Okay, now I promised to show you how to make a 5-volt USB charger, right? Well, first get a USB cable like the one your device needs. Get it from a dollar store so you don't get ripped off. Cut the head off the cable and strip the insulation. Next, clip off everything but the red and black wire. The red wire goes to your plus 5-volt line, and the black wire goes to your circuit's ground. Double check your regulator is doing what it's supposed to, then plug it all in. That was easy, wasn't it? Now you can be even more angry when people sell you car chargers for $30. Just make sure you keep an eye on the temperature of the heatsink and use a bigger one if necessary. Now, there's 2 more things that you should know about linear voltage regulators. 1, they're not very efficient. 2, they have what is called a dropout voltage. First up, the power wasted in a linear regulator is given by Vin minus Vout multiplied by the output current. So if I take the 16-volt unregulated power supply that I built, use a 5-volt regulator, and draw 300 milliamps, it'll generate 3.3 watts of heat, which is a lot for a tiny device, so a big heatsink is important. Now let's see what happens when I use another input voltage that's closer to the 5-volt output that I want. This is a 7.2 volt nickel metal hydride battery, and when it's fully charged, it'll supply 8.4 volts. If I draw the same 300 milliamp load, I get a power dissipation of 1 watt, so I can get away with no heatsink at all. In general, you want to avoid high input voltages with linear regulators because the higher the input voltage, the lower the efficiency. Now, the dropout voltage that I mentioned earlier is related to the minimum input voltage that you have to feed your regulator to guarantee a regulated output. Most of the time, your input voltage will have to be at least a volt or two above the output voltage of the regulator. So for a typical 5-volt regulator, you'll probably need a minimum input of 7 volts. Check this out. Here I am dropping the input voltage from 20 volts all the way down to 7 volts, and the output voltage doesn't even budge. Now, watch what happens when I drop it a little lower. The output voltage starts to drop, and your circuit won't get 5 volts anymore. The exact amount of headroom you need is called the dropout voltage, and it will always be given in the datasheet. You can also buy regulators that have a lower dropout voltage than normal. For example, this is an LM2940 regulator, and it has a dropout voltage of half a volt. This means that for 5 volts out, your input can drop as low as 5.5 volts before you lose regulation. Low dropout regulators are slightly more expensive than standard linear regulators, but they can be handy if your input voltage drops really close to the output voltage that you're expecting. For example, if you're trying to power a device with batteries, think very carefully about how low your battery voltage will go. So yeah, that's it. Voltage regulators are easy. Input voltage, output voltage, a few capacitors and a heatsink, and you're done. Thanks for watching.